What's that?
Clorox.
A Clorox or Lysol. Use something on those cutting boards and those surfaces. Okay, here's this one. All right. This is the type of gastroenteritis caused by the overuse of antibiotics. This is the one that people actually cause. It's basically called antimicrobial associated gastroenteritis. Now, basically, what do? You're in the hospital. So this is only found in hospital patients on long-term antibiotic therapy. They basically kill the normal flora, right? So the normal flora is gone. Now, some people actually have this bacterium. It's caused by Clostridium difficile. Okay, I used to try to find that guy in the poop lab. So C. diff, for example, is called C. diff. Some people actually have it in their gut. But C. diff is kept in check by the other bacteria, correct? Your normal flora keeps C. diff in check. Well, you're in the hospital long term, you're antibiotics long term, you kill all the normal flora. Now, C. diff has the opportunity to overgrow, makes sense? And if you have an overgrowth of C. diff, okay, it can cause pseudomembranous colitis. Now, colitis is what? Inflammation of the colon, correct? All right. Pseudomembrane means pseudomembrane. So, is it on this slide? It sure is. Now, why is C. diff so bad? C. diff has two different kind of toxins. The other guy so far had one toxin, right? Like cholera toxin was one for cholera. Or sugar toxin, one for Shigella, correct? This guy has two toxins, toxin A and toxin B. Real simple, right? That's it. Now, toxin A, its job is to cause inflammation and fluid loss in your intestine. That's his job. That's toxin A. So inflammation and fluid loss in your intestine. But toxin B causes cell death. Almost like sugar toxin. Causes cell death. So that's why this guy is really bad. So you got all these cells dying in your colon, for example. Those dead cells with connective tissue kind of fuse together, and I'll show you a picture. It makes a pseudomembrane. Make sense so far? So, pseudomembranous colitis, it is bad. Okay. I just talked about that, right? So let's go. Ooh, yeah. So here's our picture. Someone's in a colonoscopy. You're looking at their colon. And do you see those yellow lesions? Those yellow lesions are the result of cell death, right? Remember, the colon is inflamed by toxin A. Toxin B kills the cells. Those killed cells kind of come together and form these yellow lesions. That's pseudomembranous colitis. And that can be fatal. Yeah, that can be fatal. Quickly, baby. Come on, baby. Let's go. Come on, baby. Oh, we gotta go, baby. Gotta go. Oh, gotta go. Okay. Now, again, this is caused by people. Because basically it's caused by long-term antibiotic therapy. You wipe out your normal flora and you give C. diff a chance to basically take over. Any antimicrobial can trigger that disease. If you take out the normal flora, that's what's going to happen to you in the hospital. Now, how you diagnose it? Look for those toxins. Look for toxin A, look for toxin B. Find them, you got C. diff. Simple as that. You treat it with antimicrobials, but just as Leon said, you got to put some normal flora back into that colon to kind of replenish it after we're dead in the first place, to allow C. diff to take control. Now, for example, in Europe, they do something called a fecal transplant. So simply put, it's like an enema. And in that enema, they use fecal particles from someone in your household, for example. I know it sounds gross.
Oh.
What do they do that for?
They're trying to replenish your colon with normal flora. So it's an enema with fecal material from maybe someone in your house with some other fluids, and they put it back in your colon to kind of replenish normal flora in a real quick way.
But we don't do that here?
No, we don't do it here.
We don't.
That's in Europe. We don't do that here.
We don't swing that.
No, we don't. That's gross.
That's kind.
I don't want your feces in here.
Well, that's kindness,
How do
donation.
we do it?
What's that?
That's kindness. Someone is donating poop.
Well, they're donating their poop to you. That's kindness. Yeah. Well,
Yeah,
how do we do it?
that's some serious family bonding
It's
right
family
there.
bonding. We use antimicrobials, but you can just eat activity, for example. But it takes a longer time. It has to go through your system and get down there. But the enema puts them right there.
It goes faster.
Activity much better.
Activity, and it tastes better too.
But we want it instant.
Instant, yeah, instant. It's instant. Real quick.
I was reading an article about people that have weight loss is better, and some people for the whatever normal flora in their and that was what they were saying, for us getting permission to take that
Oh,
Okie dokie. Salmonellosis and typhoid fever. This is the last type of bacterial gastroenteritis, real quick. Caused by your favorite bacterium, Salmonella. Whenever you hear that, you think of bad stuff, right? It's not good. Okay? Salmonella is bad altogether. Now, the main guy is Salmonella enterica.
Enterica.
Enteric, right? In the gut. Now, Salmonella enterica is found in virtually all vertebrates except for humans in terms of microbiota. So you can find it in birds and reptiles, for example, and it's in their gut naturally, but not in yours, okay? So if it's in your gut, you got either salmonellosis or typhoid fever. Makes sense? So it's not in you, but it's found in other vertebrates naturally. Now, a serotype is basically a type of strain. So it's Salmonella enterica, and it's a strain of it. So when you hear serotype, it's a strain of the other guy. Okay. Now, Salmonella enterica, serotype typhi, or serotype paratyphi, they cause typhoid fever. Now, real quick, typhoid fever is when you got that strain of Salmonella, and it gets in your gut first, but now they get out of your gut and into your blood. So basically it causes bacteria. That's what it is. So typhoid fever is basically infection all in your body caused by Salmonella. That's typhoid fever. Now, Salmonella enterica, serotypes enteritis or typhimurium, they cause salmonellosis. Now that one you want, because that one just causes diarrhea. It resolves on its own, literally. It resolves on its own. You don't need any help from anybody. Just replace your fluids. Typhoid fever, you need help, because if you don't get treatment, it stays with you for a long time and it can kill you, because it's in your blood system. Like bad sushi. Okie dokie. Now these bacteria, they can tolerate the stomach and they pass the stomach and get into your intestines. And like everyone else, they have little toxins that mess your system up, okay? So that's standard for everyone right now. But in terms of how do you get it? Now, typhoid fever is from contaminated food or water. Real quick, remember I told you about who? Typhoid Mary, right? I told you about her, right?
Mm-hmm.
She had typhoid fever, but she was asymptomatic. Now, how does it work? Now, she acquired it from someplace. That stereotype, for example, got out of her intestines and got into organs like the liver and most importantly the gallbladder. So in typhoid Mary, you had either serotype typhi or paratyphi in her gallbladder, and they're just replicating in the gallbladder. And then they can leave the gallbladder, get back to the intestine, and get out via the feces. And that's what they're doing. So if they get to the gallbladder, you have a semi-permanent infection. They are there forever. They're there forever. That's why you got to get some treatment for that. So typhoid Mary, she didn't have symptoms, but every time she went to the bathroom, guess what she was doing? She was passing out salmonella, right? And she was a cook. So every person she worked for, she was killing them. Right? So we won't have to go back to that story. That's typhoid fever. Now, salmonellosis. Okay, how do you get that? Primarily eating contaminated eggs. That's how you get that. So eating raw eggs or handling raw eggs, how you get that. Also, handling reptiles. Because salmonella is also found in reptiles. So if you have reptiles in your home, just wash your hands after handling them. That's all. Because you can get salmonella that way. Okay. Blah, blah, blah. As usual, you can look them in your stool. Now, salmonellosis, again, is self-limiting, meaning you have diarrhea. And it resolves over a couple of days. That's it. But with typhoid fever, right, that's a semi-permanent infection in the gallbladder. You got to get on some kind of antimicrobial drugs to kill them. Because if you don't, they either kill you or you end up like typhoid Mary, you kill other people. Okay? You got to take care of that. How do you prevent it? Basically washing those hands, right? Wash your hands after handling chickens and eggs and reptiles. Now this table is 23.1. It's a good table. It talks about every single type of bacterial gastroenteritis we talked about today. I would put that somewhere in your house. I guess the garage is with all the other houses or rooms are filled with other tables. This goes in the garage. Maybe in your car. Oh, viral gastroenteritis. Now, the main difference here, viral gastroenteritis is not as bad. It's not as bad as bacterial. It's like having a stomach flu. So when you have the stomach flu, this is what you got. Now, in these types of gastroenteritis, you do not have dysentery, and you do not have bloody stool. So you only have dysentery bloody stools, mucus stools, the bad kind of stuff with the bacterial type, or even protozoan type, but not with viral. So, it's less severe. Primarily it's caused by noroviruses and rotavirus. That's the primary agent here. It's either norovirus or rotavirus. Real quick. Noroviruses affect adults and school-aged children. Rotavirus affects infants. Now, how do you diagnose it? Again, look at the stools. How do you treat it, okay? Now, with norovirus, there is no vaccine against norovirus. If you get that, you're okay, right? Let it run its course. Drink lots of fluids, drink Gatorade. That's it. Now, for example, I said rotavirus attacks babies. And there is a vaccine against rotavirus. You need to get your baby vaccinated against rotavirus. Because how do you get it? Now, norovirus comes from eating contaminated food or water. That's how you get the norovirus. But rotavirus is fecal oral transmission. That's how you get rotavirus. It's fecal oral transmission. So, for example, in the daycare center, you got a daycare worker changing diapers, right? God forbid they don't use gloves, right? And then they go prepare the kids' meals, and they didn't wash their hands.
Little babies put their hands everywhere.
And they do. The babies put their hands in all kind of places, and they put their hands in their mouth. Make sense? Okay. Now, in terms of the vaccine for the rotavirus, so babies only get between 2, 4, and 6 months. So when they're young, why is that? Well, you all had diarrhea, right? You don't have to raise your hand, but you've had it before. Is it that bad? No, it's not, right? You get over it. But diarrhea in children is much more severe, makes sense? It can be fatal if a baby has diarrhea. They can lose so much water they can die. So if there's a vaccine against the rotavirus, which is the primary cause of diarrhea in children, why not get your baby vaccinated, right? Because it can kill them. So diarrhea is a big thing in babies, not so much when you're an adult. Now, I'm not going to spend too much time. This guy is a norovirus. So see these little wheels? That's the rotavirus. So rota means like a wheel, right? Okay, so these guys are rotavirus, attacks children. They have vaccines against that. Look at that. This map is showing you places. Each dot is equal to 1,000 deaths. That's from rotavirus. Now, I don't see too much in the U.S. You know why?
There's a vaccine?
There's a vaccine against it. And like I said, the babies get it, what, 2 months, 4 months, 6 months. It's a part of their regimen. They just get it. Okay? So you don't see too many. You do get them, but not up to 1,000, right? Well, look at all the other places in the world. Those are deaths from rotavirus, which a vaccine can take care of. Why? Because it attacks babies, right? And diarrhea in babies can lead to what? Death. They get dehydrated. That's it. They die. Real quick, too. Real quick. So it's bad, but there is a vaccine against it. That's rotavirus. Viral hepatitis. Oh, I know, boy. Here we go. I know. Now, hepatitis means what? Inflammation of the liver. That's all that it means, right? It can be caused by many different things, like drinking too much alcohol, for example. It can be genetic, right? So it doesn't have to be from a virus. There's many different causes for inflammation of the liver. But we'll focus on viral hepatitis. Usually, right, you get jaundice, which is what? Yellowing of the skin and yellowing of the eyes. Now, why is that? Now, the liver helps with digestion, right? But it also helps in breaking down toxins in the body. So if the liver is damaged, it cannot break down toxins in the body. You get toxin buildup, you get yellowing of the skin, and yellowing of the eyes. All right, that's called jaundice. You can also have abdominal pain, fatigue, vomiting, appetite loss. You can have a dark urine or light stool, for example. Now, those symptoms can appear years and years after you have been exposed to the virus. So you can be exposed today, and you will never know until maybe 20 years later, you got Hep B, for example. So it just may take time for the symptoms to really show up. All right. Now, in terms of liver damage, it's caused by the immune system killing the infected liver cells, right? So if you take it back to chapter 16, correct, that'll be on the test coming up, right? You've got the cytotoxic T cells killing virally infected cells, right? So liver damage really comes from the TC cells, right? They're killing those cells infected by one of those hep viruses. All right. Now, there are 5 different types of hep viruses, and yes, we got to know them all, because I told you that in your study guide. You got Hep A, Hep B, Hep C. This is Hep D, but it's called Hep Delta, and Hep E, so A, B, C, D, they got it 5 of them. Let's go through this, okay. You don't have to know everything from the table, but I'll tell you right now, let's go to just, how do you get it? Transmission. I got a real quick, easy way to help you figure out how these guys transmit, okay? They're all in order, right? A down through E, correct? Okay, some of them are basically fecal oral route. In other words, you ate something that's contaminated with the food or contaminated water, for example. Others of them, basically sexual activity or using needles or sharing needles. All right. Notice, for example, the ones in the middle. I'm trying to help you out, right? Notice the ones in the middle are transmitted by what method? Sex and needles, right? Okay. Now, so think of it this way, okay? If the ones in the middle, if it's 5, right? The outer ones are A and E, correct? Guys in the middle, B, C, and D, right? So if they're transmitted through sex, for example, just think of it like being in between the sheets, correct?
Yep.
Right? I'm trying to help you out. They're in the middle. Notice that? Think of being in between the sheets, right? That's where you probably do that kind of stuff anyway, right? Does that help you out? That was free. Now, I know this is trying to be PG-13, but it's real simple because these guys, fecal oral, sex, right?
And just a transmission,
That's how you get it.
but you know,
Yeah, you gotta know that. That's why I said between the sheets, right?
shards.
B, C, D. Going to the middle, right?
Not the genome or the virus.
No, gosh, no. Start with this one. How do you get it, right?
Okay.
Okay. Severity, we'll talk about that, yes. In other words, this one is mild, and the last one's also mild, because the immune system can clear them out. So Hep A and Hep E, your body does a good job taking care of them and clears them out of your system. So it's relatively mild. It doesn't take you out, it's not even chronic. It's very mild. Now the ones in the middle, right? So Hep B, it can kill people, so up to 25% of people with Hep B could actually die. And I actually know someone who did that, passed away from Hep B. Hep C is subclinical, look at that, up to 4%, so not that bad. But Hep D, okay, here's the deal. Hep D on its own is not all that bad. It's not bad by itself. But Hep D with Hep B can cause some major damage to your liver and can kill you. So in other words, I'll tell you right now, Hep D does not have its own protein coat. So all viruses have what? DNA, RNA, right? And they have their protein coat. Well, Hep D doesn't have its own protein coat. He uses Hep B's protein coat, which means Hep D can only affect you if you're already infected with Hep B. Make sense? So if you got both of them together cause you havoc, and they make you sick, and they can kill you. Okay? All right, so that's that. In terms of chronic carrier state, okay, again, last guys, no and no. Why? Because your immune system clears them out. So you don't end up having that chronic state forever hepatitis. But check out Hep B and Hep C, okay? So Hep B, the reason why Hep B tends to be chronic in people, because when Hep B is replicating in your cell, for example, it actually does not kill the liver cells. So most viruses, when they leave your cell, they kill it, right? They kill. Well, Hep B, they leave your cell without killing the cell. So in other words, they stay in the cell forever. Make sense? And you can't get rid of it. So Hep B tends to be chronic. Long time, you can't get rid of it. Now, in terms of Hep C, the reason why Hep C is also chronic, Hep C, just like all viruses, tends to mutate its genome. But Hep C has no kind of proofing mechanism. None. So it has lots of mutations. I mean, more than any other Hep A or Hep B or Hep D or E. It has so many mutations, literally, you have different strains of Hep C in your own body. So far, so good? Which means what? Your immune system has a hard time keeping up with all those different strains of what? Hep C. Got it? So far, so good? I'm trying to help you. So Hep C is really chronic, so think of C as chronic. Why? Many mutations, your immune system cannot keep up. So it stays with you forever. Alright? This guy is not really chronic because he doesn't even have his own capsid. He doesn't do much, right? Again, he doesn't do damage unless there's Hep B also present in your liver. Now here are the little common names. Okay. Hep A is also called infectious hepatitis because 1 out of 3 Americans have antigens against Hep A. So in other words, many of you probably got exposed to it at some point in your life, but you probably never knew it, because why? Your immune system cleared it out, and you're good to go, right? So it's called infectious because many people were exposed to it. Now, Hep B is also called serum. Think of blood, right? B is for blood, correct? That's for free too. I'm not even charging you for that. B is for blood. That's serum hepatitis. In other words, you can find Hep B particles in the blood. That's how you can also diagnose Hep B, for example. And we'll talk about those particles today. So that's serum hepatitis. So B is for blood. C has no full name. He doesn't do it. He's chronic, so I guess we'll call him chronic. C for chronic, not the weed, okay? C is a chronic meaning, okay? Constantly in your system. Why? Because he's constantly doing what? Mutating. This guy has no name. Hepatitis delta is actually his name, so he has no name. Hep E, guess what? Enteric hepatitis, it's all in the letters, right? So enteric meaning you get it from the fecal oral route. Okay, make sense so far? Okie dokie. In terms of serious complications, all right? Again, Hep A and Hep B, Hep E rather, none, right? You clear it out. However, with Hep B, you can end up with liver damage. Well, all of them. So all three of these guys here, all three, right, in the middle. You can have liver damage, basically cirrhosis, right? Or you can end up with liver cancer. All of which can lead to death. Make sense? Okie dokie. Now, there are vaccines against Hep A and Hep B. So there are vaccines against them. Now, usually, children get Hep A, like babies get Hep A, or if you're going to an endemic region, for example, like South America or Africa or parts of Asia, it's recommended you get the Hep A vaccine because it's endemic in those places. Now, everybody is recommended to get the Hep B vaccine. Okay, that was a big chart. Golly. You all straight on that? So everything he's talking about, that's what you gotta do. Okay. Woo, boy. Lord have mercy. Okay, how do you diagnose it? Typically, initial signs like jaundice, right? Look for yellow eyes, yellow of the skin, enlarged liver, fluid in the abdomen. You can also, let's skip down here. If you have Hep B, you look for these particles called Dane particles. So Dane particles are particles that's actually in the blood. That's why it's called serum hepatitis. You find the viral particles in the blood itself. You just look at it and you see them.
Dane capital.
All right. And I'll talk about Dane particles in a minute, and then we'll go home and eat some lunch. Now, in terms of how do you treat it, guess what? There is no cure for hepatitis. No cure. So if you got Hep B, you have it for life, essentially. You got Hep C, you got it for life, right? You just have it. You cannot get rid of it. So if you want Hep, get either A or E, right? Because you can get rid of that. But the chronic ones, there's no cure. You just have it forever. Right. How do you prevent it? Well, if it's either Hep A or Hep E, right? It's just good hygiene. Just wash your hands. If it's the ones in the middle, right? Between the sheets, okay? And then no sex. Right? So have protected sex or just stay away from sex altogether. Okay?
Stay away. Stay away.
And use a clean needle. If you're going to do it, use
better
a
bring
clean
it out a clean
needle.
bag.
Okay? Have your own needle. Okay? Don't share. Don't share. Alright. Now talk about the vaccines, right? Vaccines are available against A and B only, but not the other ones. Got it? Now real quick, let's talk about Dane particles and why they are important. Now, all of these particles are in your blood. It's from Hep B, right? B is for serum. Alright. Now Dane particles, these guys here, they are actually Hep B viral particles. I mean, they are the virus. So here's a Dane particle, and it's actually a Hep B virus. Now, these other guys here, these spherical guys and these filaments, they are basically the protein coats without genomes. So essentially, they're like empty viruses. They just have a protein coat, and nothing's inside of them. They can't make you sick. Only the Dane particles make you sick. Now, why is Hep B doing that? So Hep B is leaving your cell, right? Remember, Hep B doesn't kill cells. They just kind of leave your cell. You leave your cells intact. They can either make Dane particles, actual virus particles, or they release out the spherical guys or the filaments, which are basically empty viruses. Why are they doing this? Well, all of these guys are protein coats, which means they have antigens on them, correct? Now, your immune system is making antigens against all those guys. If you have all these fake viruses, right, these empty guys are fake viruses. They're going to use up all the antibodies. Make sense?
Right.
Right? They use up or sequester all the antibodies, leaving the real guys like untouched.
It's fake out.
Yeah, it's a fake out. Makes sense? So far, so good? Yeah, so you're basically, you guys are like, I don't understand. Let's say you had 100 antibodies, right? Let's just pick a number. You have 100 antibodies floating around looking for Hep B. Let's just do some math, right? So, if you got a bunch of empty viruses, okay? These guys here, spherical or filament, they are basically empty viruses. They don't have a genome, which means they're not a virus. They're just protein codes floating around, but they look just like Hep B, right? On the outside, and you've got antibodies trying to target what? The protein code. Makes sense?
Thins
Well,
the herd.
what's that?
It thins the herd.
It thins them out. So instead of all 100 antibodies against Hep B going after the real Hep B, right, which is the day particle,
Main particle.
you got maybe 50 of them, right? 50 of them are going after the fake ones. Makes sense? Right? Which means the real Hep B lives another day. It gets to infect other liver cells to progress the infection. That's all that's doing. You're faking out your immune system by using fake viruses. They're not even real. They're fake meows. And that's how you end up with chronic Hep B. Hit it.
Now the hepatitis delta, are they assembled using the B protein codes inside the cell or outside the cell?
Probably inside.
Okay.
Probably inside. But they can only do that if you already have the Hep B.
Right.
Exactly. Okie dokie. Any other questions? Because I know Sonia's like, I got class today, lady. Wrap this thing up. Now, we will cover this next on Thursday.
Can we take this first?
You want to?
Yeah. That way.
I don't know. Because Debbie's like, no. Debbie's like, I want to be in class. Oh, you?
Okay, what was the question? What did she ask?
She asked, can you take the quiz tonight?
I took that last week.
I did.
Let me show you what you got to do.
Questions today.
This is what's left. This slide, that slide, that one, and then the worms.
That's not much, we can read
That's it. And the worms are easy. That's what you got left. That's a pinworm, by the way. That's someone's anus. That's a
Oh,
female.
Lord. Coming out?
Yeah, that's a female pinworm.
Dang.
So let me tell you real quick. You want to hear this story. So these pinworms, they live in the colon, but the females, they migrate to the anus. That's where they lay their eggs, in the anus. It's common in children, real common in children. Why they do that? Because it causes itching. Itching, itching, itching. That's how you spread the eggs. You scratch down there, the eggs get under your nails.
it.
And that's how you spread the eggs around. And they only do it at night. So you wake up itching. Because at night they migrate to the anus and they lay their eggs and they go back up. Those are the eggs right there. And when you scratch down there, you're picking up the little eggs under your nails and then you touch everything. And that's how you spread the eggs around.
Oh,
In some way, some people that I know, what they did was, because they needed to prove it, they would put Scotch tape.
It's the tape test. Yeah, exactly. So yeah, that's what you got to do. So to prove that you have a pinworm infection, literally, you're right. As soon as you wake up in the morning, as soon as you wake up, you take some Scotch tape, you put it to your anus, you take it off.
all the
Because you get the eggs on the tape. And that's how you prove you had a
They're like
pinworm infection.
visible.
Yeah, they're invisible. They're microscopic. I mean, look at this. That's the size bar. It's 50 micrometers. They're microscopic. So you got to get them on the tape, take it to the doctor, and say, look at my piece of tape. You can see them. You can see them?
I ain't gonna tell you where this tape came from.
The worm or their eggs?
The worm.
Yeah, the worm, yeah. The worms, yes. The eggs, no. The eggs are microscopic, but you can see that. I mean, that's someone's anus. And that's the female coming out to lay her egg at nighttime.
Remember when you open the